Hi everybody and welcome back. Today we're going to be talking about algebraic expressions, specifically simplifying algebraic expressions. And so before we go ahead and actually simplify them, we do need to talk about a couple of different things in terms of in terms of vocabulary. Okay, so I want to make sure we're all using the same vocabulary, and that is the vocabulary that pretty much every mathematician uses, and we're training to be mathematicians. So that's what we want to make sure we're doing. So a term is a single number or variable, or numbers and variables multiplied together that contain variables. Okay, terms are separated by positive or negative signs. So for example, the terms here are 4x and 7x because they're separated by the negative sign. Okay, and the 4 is a number, the x is a number, and it is being multiplied together. So that would be considered a term. Okay. And then the 7 is also considered a term because, again, it's separated by that negative sign. All right, so that's something for us to keep in mind. That is what a term is. Okay, and I'm just going to erase my marks here. Okay. A coefficient is the number that is attached to a term with a variable in it. So that's what a coefficient is. So if we look to the left here, the coefficient in this exact same expression is going to be the 4. Okay, that is our coefficient because it is the number that's attached to the variable. Variables with no numbers are going to have a coefficient of 1. So I like to think about it, it's whenever you have, say, for example, x just by itself, then the coefficient is going to be 1. I like to think of that 1 as being almost like an imaginary friend. We know it's there, okay, we just can't see it. Now, a is a symbol that represents a number that we don't know yet. So a variable is a symbol that represents a number that we don't know yet. Is usually a letter like x or y. So the variable in this particular expression, 4x minus 7, is going to be x. X is our variable. And then the last term, the last vocabulary word that I want to introduce here is the word constant. And a constant is a fixed value with no variable attached to it. So a constant here is 7. So 7 is going to be our constant, okay? Because that is just a number. It does not have a variable in it at all. So the first exercise that I want us to do is talk about what the coefficients are in the following terms. So 3x to the 4th. The coefficient for this would be 3. Negative 5xy squared. The coefficient, which is just the number, is negative 5. The coefficient for z to the 4th, this is our imaginary friend, 1. And then here's a tricky one, the coefficient for y squared divided by 7. You can rewrite this as a fraction, 1 over 7 y squared, which means the coefficient is 1/7. Okay, so now that we're all on the same page of what the vocabulary words are going to be, let's talk about like terms. Okay, so a like term are terms whose variables and their exponents are the same. Okay, so I have a list here of potential like terms. And if we take a look, I'm taking a look at the variables. All of these have x's and y's. And I want to make sure that the exponents of those x's and y's are the same. And in this case, they are, because I have x, and then the exponent, even though we don't see it, is a 1. And the exponent for all of these x's are 1. And then the exponent for all the y's are 2. So all of these are like terms. Okay. So the other part of this is that you can combine like terms by adding or subtracting the coefficients of all the like terms and keep the variables the same. So we're going to keep all the variables the same. All we're going to do is combine or add and subtract just the coefficients, just those initial numbers. So in order for me to do that, I'm actually going to highlight my like terms. That's what I'm going to do. So for my first example, and we're not going to do all of these problems, we're going to do a few of these, or I'm going to skip around. But what I want to do is I want to find my like terms. So if I have 6.2, that's really not important to us right now when we're identifying the like terms. What's important to us is the x. I need to find another term in here that has x. And I found one. Now the next thing I'm going to do is I'm going to grab a different highlighter. We'll do yellow. And I'm going to kind of see, is there anything else that I can find that I can combine together? And I notice that this -4 is just a constant, and this -1.2 is also a constant. So now all I have to do is I'm going to go ahead and combine my like terms. So I'm going to take my two green ones and combine them together. So I'm going to have 6.2x, and really that's a 1. We assume it to be a 1. X. So I'm adding 6.2 and 1. So this would be 7.2x. And then I'm going to add together the -4 and then the plus -1.2, meaning to say my answer is going to end up being negative. And I'm just adding the 4 and the 1.2 together, so this would be -5.2. And that right there is going to be my answer. All right, so that was kind of an easy one. Again, I highly recommend, especially if you're having trouble identifying the like terms, I really recommend highlighters for this. Now, I'm going to go ahead and actually skip to number 5. Okay, so I did 2. I'm going to skip to number 5. And before I even try to figure out what my like terms are, I actually notice that I have numbers before, and then I have groupings. I have parentheses. So I'm going to use the distributive property, and I'm going to distribute my numbers. And I always like to circle them because it kind of tells me the signs. I like to add the signs with them. So I'm going to go ahead and distribute the numbers first. So I'm going to do 3 times 2x, which is 6x. 3 times -5, which is -15. -5 times x is -5x. And then -5 times -4, which is the +20. Now I'm going to go ahead and highlight. So I have 6x, and that is a like term with -5x. And then I have my two constants, which are just my two numbers, which is -15 and +20. And now let's combine. So I'm going to combine my two green terms together. So I have 6x minus 5x, which is just going to give me x. And then I have my -15 plus 20, which is a +5. So that would be the simplified version of this algebraic expression. All right. Let's go ahead and do problem number 9. Okay, and then we're going to call it a day. So again, just like before, I noticed parentheses, so I'm going to try and get rid of them. And I'm going to distribute that negative. And keep in mind, if I don't have a number, I assume it to be a -1. So I'm going to multiply -1 by every term inside my parentheses. So negative 1 times 2x squared y is negative 2x squared y. Negative 1 times times positive 3z is a negative 3z, and then everything else stays the same because that is outside of the parentheses. So just like we did in the previous examples, I'm going to start highlighting. So my first highlight is going to be that first term where I have x squared y. So I need to find a term that has both an x and a y, and the x has to be squared. And I found one. I do have one, and it's my last term right here, which is negative 5x squared y. Perfect. All right, and then I have my next term, which is that negative 3z. So I need to find another term that has a z, which I have, and that's that positive 3z. So now I'm going to go ahead and do what I've done before, which is combine my like terms. So I have negative 2 minus 5, which is negative 7, and then my variables stay the same. And then last but not least, I'm going to combine my yellow terms together. And actually, I have negative 3 plus 3. Those are additive inverses. So actually, these two cancel out to be 0. So this is my final answer. Okay. So we are going to go ahead and do some practice. So I'm going to pause this and let's get started.